Hello everyone, my name is MAGENDRAA. My metric number is F24B1004.
Hi everyone, my name is SOFIA from FAIZAL. My metric number is F24A1301.
Hello everyone, my name is Ahrini Nagendran. My metric number is F24A1218.
We are from group SBF group 11. For this project in FFT2073 basic statistics, our group analyzed data set A, which contribute 200 of observation involving two categorical data types, type A and disease resistant. The data types are three categories, there is type A, type B and type 3. While disease resistant is F category 2, that is resistant and non-resistant. This project is joint frequency distribution table and signified relationship. That's all from me.
Next, I will explain about our research question. So, we analyzed that the relationship between two categorical variables. The research question for this study is there a significant relationship between diet type and disease among patients? In this study, we are analyzing two categorical variables. The first variable is diet type, which consists three categories: diet, diet A, B, and diet C. The second variable is resistant, which has two outcomes: resistant and non-resistant. This research question is specific and measurable because we can count the frequency of disease resistance outcome under each diet type using the given data set of 200 observation. So the next is our hypothesis. The new hypothesis states that there is no significant relationship between diet type and disease resistance. So the second is the alternative hypothesis state that there is a significant relationship between diet type and disease resistance. In other words, disease resistance depends on the diet type. This hypothesis is tested at 5% significant level. Next part is our selection of statistical tests. Now we select a combined statistical test, which is T-square test of independence. The test is combined because both variables are categorical and summarized in a joint frequency distribution table. We want to test whether there is an association between diet type and disease resistance. Therefore, the T-square test of independence are the most suitable for this study. The last part of my explanation is assumption of the test. Before conducting this test, we must check the assumptions. The assumptions of the T-square test of independence are: the data are categorical, which is satisfied as both variables is counted only once. For observation independent, meaning each patient is counted only once. Expected frequencies are sufficiently large, generally at least 5 in each cell of the contingency table. Lastly, the sample size is adequate, and in this study we have 200 observations which meet the requirement. Since all the assumptions are justified, the T-square of independence can be validly applied.
Now that we have defined our goals, we need to look at our data processing. We started with a raw data set containing 200 individuals' observations. While the raw list shows us every patient's specific diet and resistance status, it's impossible to see a trend just by looking at a long list of trends. To solve this, we use statistical software to perform a bivariate analysis. This means we took those two variables, diet type and disease resistance, condensed them into a single organized format called a joint frequency distribution table or a contingency matrix. This is the foundation for all math that follow. Our matrix is structured to show the intersections of our variables. In the rows, we have independent variable, which is diet type. In the rows, categorized into group A, group B, and group C. And we have our independent variable disease resistant, which we've categorized as either resistant or non-resistant. The reason we use matrix format rather than simple bar charts at this stage is to see joint frequencies. Each cell represents a specific subgroup. For example, a patient who followed diet B and was found to be non-resistant. Let's look at the results of our tally. For diet A, we summarized 67 observations total, finding 49 resistant and 18 non-resistant. For diet B, out of 67 observations, 50 were resistant and 17 were non-resistant. And for diet C, out of 66 observations, we found 50 resistant and 16 non-resistant. It is very important to verify this. As you can see, our column table and row tables both sum up to exactly 200, which confirms that every single observation from our original data set has been accounted for without error. By summarizing the data this way, we've moved from 200 lines of raw information to just 6 key observed frequencies. This table is essential because it allows us to visually compare the diets. At a glance, the counts look quite similar across all 3 diets, which makes us wonder, is there actually a significant difference, or is this just a random variation? To answer that, we'll move from this descriptive summary to our inferential analysis using these specific values to calculate our chi-square test statistics.
Based on the chi-square test of independence, now I will explain the statistic test output from the studies. After forming the joint frequency table just now, we formed the chi-square test of independence using statistic software such as Excel. This significant level is alpha set as 0.05. To form the software output, the chi-square statistic value obtained 6.21. The degrees of freedom is calculated using the formula, the number of row minus and times with number of column minus 1. So we will use 3 minus 1 times 2 minus 1 equals to 2. The p-value obtained from the test is 0.045. Since the p-value is lesser than 0.05, we reject the null hypothesis. This means that there are the statistically significant relationship between diet type and the disease resistance. Therefore, the results suggest that disease resistance among patients depend on type of their diet consumed. So here is the conclusion of this project. Based on the statistical analysis conducted by the project, chi-square test of independence was used to examine the relationship between the diet type and disease resistance. At the 5 significant level, the test results show there is sufficient evidence to conclude that diet type and disease resistance are associated. This means that the level of disease resistance among patients differ depending on the type of consumed. Therefore, diet type may play an important role in influencing disease resistance, and this finding highlights the potential impact of dietary choice on health outcomes. In conclusion, the analysis supports the idea that diet type and disease resistance are not independent of each other. So that's all from us. Thank you.